Hi, for this video what we're going to do is we're going to use a graph to help solve a polynomial inequality. So with this one, basically what you're looking for, I have two different scenarios because these are the two things that you could be asked, whether it's going to be greater than or less than. It could be greater than or equal to, it could be less than or equal to, it could be just greater than. But for all of them, you basically are doing the same thing. With this greater than or equal to 0 means we're looking for all x values where y is positive. So we're looking for positive values in y. So if we look at our graph, we can see that from this portion right here and this portion right here are both above the x-axis, which means that they have positive y outputs. So that's what we're looking for. So when you have a graph, you simply are just looking for the intervals. If you're using interval notation, you always start from left to right, and you're just going to report the x values. Since this is greater than or equal to, that means that it includes 0. So it includes the point where it crosses the x-axis. So for this one, it does include the x-axis. If it was just greater than, it would not include those points. So starting from left to right, we can see that starting at -infinity all the way up to -1 on the x-axis, that yields a y value that is positive. So we would start with -infinity, and all the way from -infinity until -1, our values are above the graph. So at -1, it does switch. Because it includes it, we would use a bracket. And we do have another interval where this also occurs. So from 1 to 3 is also the x values that would make y positive. So if I plugged in any number from 1 to 3 into the equation of this graph, it would give me an output that is positive. If you're working in set notation, I would say more likely interval notation is probably going to be used, but if you are working in set notation, you would just say the set of all values of x such that x is less than or equal to -1. Less than or equal to -1 just means below -1. Or from 1 to 3 where it's included. So it includes both 1 and 3. So for our second one, we're now looking for all values where our y values are less than 0. So now we're looking at these values down here that fall below the x-axis. So we can see, and this time it does not include the 0 because it's just less than. So we're looking only for the negative outputs. So we can see that from -1 to 1, not inclusive, so that means we would use a parenthesis. So from -1 to 1, it would yield a negative output, and then any values over 3, so from 3 to infinity, would yield an output that is less than 0. Had this been less than or equal to, we would have used a hard bracket at the 3 and then around both of these. For set notation, just in case you need to use set notation, you would just write it as x such that x is between -1 and 1. It's not inclusive, so we would not put the equal to. And then for all values of x that are greater than 3. As always, thanks for watching. If you have any questions or have some other topics that you need me to cover, please just let me know.